Hi guys, today we've got a problem where it's asking us to show that a particular equation is true, given that the variables in the equation are related such that 3 to the x is equal to 4 to the y is equal to 12 to the z. Now, basically, when we have the variables in the power like this, what you kind of should click in your head is we need to solve this, or the way we're going to prove this is using logarithms. So because the variables are in the power, logarithms need to be used because that's the only way you can do it. Now, the actual answer to this question is quite involved, and I'm pretty sure that halfway through you're going to go, what the hell is the point with this? Well, you're probably right, but what's the point of anything, to be perfectly honest? If not, we could have some fun going through it. So, what we're going to do is we're going to start by getting the variables out of the power using logarithms. So what I'm going to do is I'm going to take the log of each of these. So what I'm going to do is I'm going to take the natural log of each of these. So just to make the working out a little bit easier. So I'm going to go the natural log of 3 to the power of x has to be equal to the natural log of 4 to the power of y has to be equal to the natural log of 12 to the power of z. So what we can do here is we can use the logarithmic law that if we have the log of any number to the power of another number, we can say that that is the power multiplied by the log of the number. So what we're going to do is we're going to take advantage of this log law to move all of the variables which at the moment are in the powers and basically unusable to get them as coefficients in front of each of our logarithms. So what we're going to do is using this, we're going to go, this is going to be equal to x times the natural log of 3, which is going to be equal to y times the natural log of 4, which is going to be equal to z times the natural log of 12. Now, once we've got this sort of equality sorted out, we need to get our equations in terms of x's and y's so we can actually start trying to put together the right-hand side of this equation we're going to try and prove. So what we can do is we can use the fact that x ln 3 is going to be equal to z ln 12 to show that, I'll change colour, to show that x is going to be equal to z ln 12 divided by the natural log of 3. And similarly, we can find y by going, this is going to be equal to z ln 12 over, instead of ln of 3, it's going to be the ln of 4, or the natural logarithm of 4. Now, the reason I've done this is because I can start putting together the numerator and the denominator in the right-hand side of this function. So I can now show that x times y is equal to z ln 12 over the natural logarithm of 3 times z ln 12 again over the natural logarithm of 4. So what we've got here is this can be expressed as z squared ln 12 ln 12 all divided by ln of 3 ln of 4. So that's what we can say that xy is going to be equal to. Now for the denominator, x plus y. So let's change colour again. X plus y is going to be equal to z ln 12 divided by the natural logarithm of 3 added to z ln 12 divided by the natural logarithm of 4. Now what we have to do here is if we want to create a single fraction, we have to have the same bases. Now hopefully from your year 8 maths, or the maths you did when you were 13, you'll know that to get the same base in this sort of situation, we can multiply the bases together. And what we're going to have is we're going to have x and y equal to, let's put a long fraction line. And at the bottom we have ln 3, ln 4, so we've multiplied the bases together. And on the left hand side we're going to have z ln 12 times the ln of 4 times the natural logarithm of 4 plus z ln of 12 times the natural logarithm of 3, ln 3. So what we can do here is we can factorize the numerator. So what I'm going to do is I'm going to just move this to there. So we can factorize the numerator by going by z ln 12. So that will be z ln 12 outside of the natural log of 4 plus the natural log of 3. And all of that is going to be divided by ln 3 ln 4. Cool. So what we can do is using another log law, we can say for this part inside the bracket here, we're going to use the log law like ln of a plus ln of b is equal to ln of ab. So if we've got two logs with the same base adding to each other, we can effectively make them into one log and multiply them together. So what this is going to be equal to, we're going to have z ln 12 times 4 times 3 is 12. So we're going to times it also by ln of 12. All divided by ln 3 ln 4. Cool. So now we've basically got two simplified expressions for what x times y is and what x plus y is. So what we're going to do, hopefully one of these colours will work. Let's have a go at it. I'm going to just separate this. Great. So now what we can do is we're going to go, well, x, y divided by x plus y is going to be equal to, well, xy is this, z squared ln 12 ln 12, and that's over ln of 3 ln of 4. And what we're going to be doing is we're going to be dividing this, dividing this by x plus y. But instead of writing this down twice, what I'm going to do is I'm going to multiply by the reciprocal of x plus y. So I can multiply this by ln of 3, ln of 4, divided by z ln of 12 ln of 12. Now what you're going to hopefully notice in this situation now that we've got is basically the xy and x plus y are almost the exact opposite of each other, or the reciprocals of each other. So what we're going to be able to do is these two are going to cancel out and form 1. And so are the ln 12s. So what we have now is we've cancelled out the ln3, ln4s, and they form 1. And we've cancelled out the ln12, ln12s on the numerators and denominators, and they also form 1. So what we're left with is z squared over z, which is equal to z to the 2 take 1, which is equal to z. So what we can say is, after all of that, hence z is equal to xy divided by x plus y. And that is all she wrote. So basically, this is a very involved question that requires you to identify that if we have the variables in the power, we have to use logarithms. After you've done that, after you've used the logarithms to get the variables out of the power, we then have to set up equations in terms of single variables so we can build the right-hand side of this equation we're trying to prove. Once we've built all of the variables for the right-hand side, we then have to compute them, or take like the quotient of xy over x plus y. Once we've done that, it's just a matter of algebra and making sure you don't make any silly mistakes, and you will eventually pop out at the answer. So I hope that helped, and I'll see you again next time.